All right, for this demonstration, I have a compass, which right now is pointing towards north. And I've got a wire and a battery, just to show that as electricity runs through the wire, it creates a magnetic field. So you can see that magnetic field with the compass, because the compass causes that needle to move. If I turn the power on and off the right frequency, I can get it spinning pretty fast, which is basically how all DC motors work. So an electric motor just takes alternating current or just DC current switching on and off and turns that electricity into mechanical motion of the motor. In this case, our compass is acting like a little motor. Thanks for watching. Right, so as we saw with the compass, if we run electricity through this wire, it turns into a little magnet, and so it can push and pull other magnets. I've got a battery set up here balanced on top of a magnet, just using this washer to help give it a stable base so it doesn't fall. So this is a piece of wire that is touching the top of the battery and the bottom of the battery, so electricity is running through it, and it will keep spinning as long as there's electricity running through the wire. It's pushing and pulling it and turning it into a motor. It will spin a little faster. We put it on the other side of the battery, so it's turning off less often, but it spins a little too fast. I have to play with it a little more with the balance on that part. But you can see that basically the wire is bouncing on and off of the magnet, turning that circuit on and off, keeping it spinning. So this is a coil of wire that I've made with some magnet wire. The red enamel you see there is an insulator. When I've scraped it off in places to expose the copper conductor on the inside. And so what that does is when I connect it to a battery through these paper clips, it's basically turning on and off depending on the orientation or what side it's on. If I get it close to this magnet, that electricity pushing and pulling on that magnet causes the coil to spin. So this is just a slightly more complicated version of our motor that we just showed. This is a motor that I got from Goodwill. I'm not really sure what it came out of. As you can see, you got coils on the outside, and the rotor, the part that spins on the inside, also has coils. But you can see the brushes here that rub up against the commutator. This was basically flipping the electrical current over and over and over. So it's basically changing the direction of the magnetic field, probably on the stator, which is the part on the outside. And here's a even bigger one. This is from a big industrial fan. So in this case, this part is the central part, the stator, and this is, or excuse me, this is the rotor on the inside. This is the stator, which is wires. You see there's a few different sets of wires in there. And then this is the part that actually spins. And when it spins, it also spins the whole fan. So that assembly just sits down on top of there. Be careful. Busted my finger when I was taking the second part. This is the back of the fan. You'll notice in there, again, it's got some little switches and brushes to change the current. But even the biggest electrical motors are all kind of the same. You've got a magnet and you've got a coil. Sometimes the magnet is made out of coils too. So basically you've got electromagnet inside a bigger electromagnet in all these different motors.